Before we get into factoring a difference of two squares, let's start by recalling something that's rather important to this. I want you to recall what happens when you multiply conjugates. An example of multiplying conjugates is two binomials maybe where one is x plus 3 and the other one also has x and 3, but instead of a plus it has a minus. So these two things are conjugates because they're the same, except one is a plus and one is a minus. When you multiply this out, what happens is parts of it cancel. So x times x, well, that's x squared. So we've got x times x, 3 times negative 3, that's negative 9. Notice it's negative, and it will always be negative when you multiply conjugates because this guy's positive and this guy's negative. And a positive times a negative is always a negative. So the last term when you multiply conjugates is always negative. Then you want to gather all the terms with x. So you've got a negative 3x here and a positive 3x there. So you get negative 3x plus 3x. Now, conjugates will always result in opposites in the middle, meaning when you add those together, they will cancel out. So with conjugates, your last term is always negative because of the plus and minus, and your two middle pieces always cancel because one is positive and one's negative, and they're the same. So we end up with x squared minus 9. When you multiply conjugates, you end up with something like this where there is no middle term, so there's only two terms. And now what we want to do is look at how to factor something like this. In other words, how do you start with this and go backwards to the factored form x plus 3 times x minus 3? The other thing about this is, notice the x squared came from x times x. So the first thing is always a perfect square. It's always something times itself. The last number is always a number times itself also. In this case, 3 times 3. So the first term and the last term you get from multiplying something by itself. In other words, it's called a perfect square. That's why we're going to call this factoring a difference of two squares. And I could have written perfect squares there. So when I look at this and I want to factor it, I think, well, there's no middle term, so maybe if I go to set this up, it's not a trinomial, right? When I go to set this up, I'm going to set up my two sets of parentheses. Of course, I would look for a greatest common factor first, and there's nothing that's common to both of those. And then if I want it to be conjugates, because there's no middle term here, I know I'm going to have a plus in one and a minus in the other. And I know what goes here and here has to multiply to give me the 9x to the fourth. And these two things have to be equal. So to get the 9, each of these would have a 3, right? And to get the x to the fourth, each of these would have an x squared. All right? 3x squared times 3x squared is 9x to the fourth. Now the last two terms have to multiply to give me the 25/36. So when I multiply these, I have to get 25 over 36. And in fact, it should be negative. And we can see that it will be because this number is going to be positive and this number is going to be negative. Now, if these two numbers have to be the same, because the two binomials are conjugates, well, 5 times 5 is 25, so I'll have a numerator of 5, and 6 times 6 is 36. So I'll have a denominator, sorry, I said it right, but I wrote it wrong. So 6 times 6 is 36. So now you can see that when I multiply positive 5/6 times negative 5/6, I get negative 25/36. Now what we need to verify is what happens when I multiply these two guys here, right? I'm going to get, well, here, let's do this. Let's check our answer. Let's be more formal here. So I'm saying we're done here, but let's check our answer and multiply this back out. So the 3x squared times the 3x squared is 9x to the fourth. The 5/6 times the negative 5/6 is negative 25 over 36. Here I get a positive 15/6 x squared, and out here I get a negative 15/6 x squared, and in fact those cancel as we should expect, and so we do end up getting what we wanted, 9x to the fourth minus 25/36. So see, that middle term cancels out if you multiply conjugates, and we needed it to because the original polynomial did not have a middle term. There were only two of them.